and welcome to my workshop. If you'd have watched my last video, you would have noticed that I snapped my extended 3mm ball mill. Well, I put a new one in it, which meant brazing into this piece of shaft, and I put it in the machine and immediately broke it again. But this time it was probably because I overcooked it and made it a bit brittle and snapped it off. So today I'm going to do something permanent about it. I'm actually going to make a chuck to hold my 3.5mm ball mills and my 1.5mm, oh there it is, 1.5mm ball mill. I don't know where the camera is focusing on that. I think it might be. So that's the two. So what I'm going to do, I've tried to find a bit of material around the place, and this is probably the proper type of material, but it's much too big. This is 4140 or shaft steel, and this is mild steel. Well, if I turn this down to about 10mm, which is going to be the shaft size, not only is it put a lot of waste of material, but mild steel is probably not the best material to do it with. It will flex or bend. This is chrome steel, and I could do it out of this, but this is only 8.5mm. Now what I need to do is, this is an Allen key, and this is a grub screw or an Allen screw, and so what I'm going to need to do is first of all drill a hole up the center, the size of the shaft of the 3mm and 1.5mm ball mills, and then drill in through the side in two positions and thread it this size so I can clamp it inside. So there's not enough material for me to actually do that with. If you can imagine, I need to get the full depth of this in, and there's just not enough material there. So the only thing I can do is, now this is quite a hard steel bolt, and I'm just going to machine the head off it, machine the thread off it, and clean it up a bit, bore the center out, drill two holes through the side and thread them, and we'll make a chuck out of, or an extended drill chuck then, or mill chuck out of a bolt. So here we go. Okay, I've got the bolt now in the 3-jaw chuck, and the first thing you'll notice is that I've actually cleaned my lathe. So, long overdue. So the first job we're going to do is we're going to machine the head off. Okay, now I've got down to the diameter that I'm happy with. I'm now going to face it off. So we're going to put it on automatic feed this time. Okay, this is a center drill. You'll notice it's very stubby, and it's got a drill at both ends with a fine tip type drill, and then which tapers out. This is to reduce the amount of flex. So when this is brought into the material, it stays absolutely true to the center and it doesn't flex one way or the other, and it gives you a very true start then to a hole in a piece of metal. So that's what we're going to do next. Perfect. You see, that's where the flute starts, right there, and we're just down to that. So we've got the maximum amount of the shank inside here now. So what we're going to do now is machine the other end of this now piece of bar, and then take it over to the mill and mill a flat on here, and then put 2 holes in it, and then thread them to be able to clamp this. I'm not really interested about this bit here, that really doesn't matter. I'm just going to machine the threaded area down and probably leave a bit of a gap here, because it's really not gripped by anything. Okay, you notice now I've drilled a taper in there, the same shape as that, which matches up with this. This is what is known as a dead center. In other words, this doesn't rotate at all. I'll show you the difference. I just got a live center. This is a live center. It has a bearing here, so the pointed bit actually rotates with the material, and this gets put in there, but this area what holds the bearing just prevents me getting the tool in this tight area. So that's why I'm using a dead center is in here. Perfect. So we'll get a bit of oil on there. Hold it up just a little bit, and now we can continue machining. But we obviously, when you get down to these small areas, confined areas, you've got to be just a little bit more careful. Okay, so basically that's what we've got now. This is the area that gets held in by the collet or the chuck in the router, and that's where the ball mill goes. Okay, this machine is my milling machine. So what we're going to do with this machine is we're going to machine a small flat on this, then drill down through, and then we're going to thread those to make the clamping device. So for those of you who are not familiar with the mill, I'll just give a short description of how it actually operates. Well, first of all, this is the headstock. In here is a big gearbox, electric motor on the top, and I can change gears, a little bit like changing gears in a truck. High and low, and high, low, medium here as well. Switch on forward and reverse on this machine, so that's forward, reverse, similar to a lathe. I can select different speeds. That's 1600 RPM, that's maximum speed for this. And this is a compound slide work bed. So you have a handle here which accurately, within a thousandth of an inch, move the bed in and out, or the Y axis. And here you have another screw which slides the bed in the X axis, and the Z axis is a little bit like a drill. You can actually pull it down manually like this, or you can actually engage the very, very precise adjustment for the Z, but this is all manual. Because this machine is normally used for machining or working metal, it works on a very different, level of rigidity, shall we say. In other words, you have to hang on to the parts quite a lot sort of tighter or better. So what we normally do, this is what they call a T-slot tie-down bed, or these are the T-slot ways, and these are actually the T-slot nuts. And this is a method of holding things down onto these beds. Let me get it in. This is just used as a spacer. And that. The first job we need to do is to get this running true to the actual chuck. So I'll get my DTI gauge to do that. I think I actually just said a magic word, actually, DTI gauge, which is what this is. It's a dial test indicator, and this measures in 0.001 of a millimeter, which is less than a thousandth of an inch. So what I've done is I've got to bolt this end and I bolt this side. I've tightened this one up, and what I'm going to do is I'm going to be running along this face here to be able to get this square, running square with the bed. So what we're going to do is we're going to set this on 0. Wherever 0 is going to be. See, the slightest minute that's pretty damn good. So now tighten up that side. Notice the gauge move there when I tighten this down. I'll alter a little bit. There you go. That is pretty well damn perfect, actually. Okay, so I've lined the tool up now, and now we're going to machine it just a small flat on one surface there. Okay, this is where I'm going to put the first hole, and this is 5.5 millimeters in from the end. Actually, this is an imperial drill. I'm not quite sure of the size, but I can tell you it's 4.4 millimeters, which is an odd number. There you go. Okay, now all I've got to do is tap a thread. If I can stay out of the light so you can see. The idea is to get the tap started and do a complete turn, then back quarter of a turn, and that breaks off the swarf from out of the thread being cut. Just like that. That's why I drilled the hole all the way through too, so I could tap the thread all the way through, because, well, I'll show you in a minute when I get this in. Okay, if I just wipe that off a bit. You can see, if I can get this to focus, you'll see there's very little threads down here. Oh, if I can pick it up so you can see, there's very little threads there, and it gradually gets deeper and deeper and deeper as you go further up the tap. This is a tapered tap, so what it does is starts off the thread in the hole very gently, and then gradually cuts deeper and deeper and deeper as it goes further in. So that's one reason why I had to drill all the way through this material, and indeed take the tap all the way through to get a good full thread on this side. Okay, having just cleaned it up, we'll put this grub screw in and get this one. Put that one in, I'll just get it started. Then we get our 3mm ball mill and get him all the way home. Do that one up, do that one up, and there you have a chuck. Now that can interchange from one type of cutter to another. And if I snap one off, I don't have to worry about brazing anything. And there you go, it's a simple little tool, and this actually is tool making. So if ever you hear the phrase, oh, he's a tool maker, well, this is the sort of thing that they do. They make, or one of the things that they do, make precision tools to carry out another job. So there's a chuck, a very simple chuck. So there you go. Simple I hope chuck. You've enjoyed this hopefully short video for this tool making or chuck video. As usual, please, if you've liked the video, please subscribe or press like. Pass it on to your friends if you think they would like it. And as always, little red box up there, if you press that, that'll take you to my YouTube channel, where hopefully you'll find something that you like there as well. So for me now, it's bye for now.